In this video, I'm going to show you how to run PHP locally and detect tampered data with HMAC. So HMAC stands for Hash-Based Message Authentication Code, which is a hash plus a secret key used to prove a message wasn't changed. This demo uses one built-in PHP function, which is hash_HMAC, and there'll be no libraries needed and no extra setup. The first pre-step that I did is to use the pre-tags, and this is so that the output formatting works in the browser, basically just for looks. So the browser will usually ignores new lines by default, so pre-preserves spacing and line breaks. In the first step, what we do is we will define the original message. This is going to represent data being sent over the network. And so the message is a string that says transfer $1,000 to Adam and is stored in a variable called message. In step 2, we define the shared secret key. The secret key says super secret key is a string and is stored in a variable called secret key. And in this case, both the sender and receiver must know this secret. This makes HMAC a symmetric mechanism, which means the same key is going to be used in both sides. In step 3, the sender generates a HMAC and sends it with the message. So we can see how that HMAC is being generated. First, we are using the function hash_HMAC, and using the SHA-256, this will always produce a 256 bits of output. This is the hashing algorithm that's used. And then HMAC, what it will do is it will combine the message with the secret key. So the final output is going to be stored in a variable called sent HMAC, and this is going to be used to provide integrity and authentication. All right. So in step 4, we're basically just displaying the results to see what the sender has actually sent. So we're just sending out or echoing the original message and the generated or the produced HMAC. So let me show you how this works or what it looks like at this point. So I'm going to just cut those lines and then I'm going to save it. Now, I just want to show you how this is looking like in my package explorer. I've got the file hmac_demo.php. That's the name of this file. And it's sitting in a folder called php_mysql. This is basically a folder that has any topics I create on PHP or MySQL. So this is really not relevant to MySQL, but I do use the same folder for both types. So it's actually sitting in my documents. And if you try to drag that and put it in the browser directly like this, it won't work. Like nothing, as you can see, nothing happens. It's just pretty much displaying the text as is. That's because there is no server to run the PHP. Remember, PHP is a server-side scripting language, so we do need a server. So to reflect the topic of this, or the title of this video, which is how to run PHP locally, let's fix this by starting a local PHP server, which will execute the code and send the output to the browser. To do that, I'm going to open a new terminal, and I'm going to type in the command PHP capital S, so dash capital S, and space localhost and port 8000. So what that pretty much means, start a PHP, so start that S is for start, a PHP web server on my computer, so that's localhost, on port 8000. So I'm just gonna enter to make sure that it actually worked. So we can see that the server started. So to view the file, we're going to come back to the browser. And then what we need to do is type in the URL. So you can actually see it. It's the first one in my list. So we ask the local PHP server to run this file. and send the result. And we'll be using the same port that we have started the server from. So we can see the original message, transfer $1,000 to Adam, and here is the HMAC that's been sent by the user, this value. So it doesn't matter what this value is. What matters is that the next generated one that's going to be generated by the receiver should match this code. That's what matters. So now I'm going to bring back the rest of the code that I just deleted, and we'll come back here and look at step 5, what happens at the receiver's side. So the receiver receives the message and the HMAC. In real system, the HMAC usually comes from an HTTP header or request metadata. So the received message is the original message, and the received HMAC is the one that's been sent by the user. So in step 6, now the receiver will need to recompute the HMAC locally using the same function again. And so the receiver in this case will never should not trust the incoming data. It should recalculate the HMAC again itself. So although it's got the received message and it's got the received HMAC, however, it should still recompute it. So it's going to recompute it using the received message and the secret key, and again using the same SHA algorithm, hashing algorithm. Okay, so now we have a recomputed HMAC. So the receiver, what it will do now is it'll compare the received HMAC with the recomputed one. So it's going to be using the hash underscore equals function to check the equality. So in this case, it's going to prevent timing attacks. So it's using an if function and passing in the arguments. Here, we're just checking the equality of the received HMAC that came from the user and the recomputed one that it did locally at its end. If they are the same, in that case, this integrity is confirmed and the message is valid. If the message was tampered with, then it will execute the else method. So let me cut off this part and save, and let's see what this looks like in our browser. In this case, the message was valid. So this was the one sent by the sender, and the one that was recomputed by the receiver actually matched. And so in this case, we got the message was valid. Let's simulate an attack. So in step 8, the message is modified while in transit. So here we see that the message changed from 1,000 to 9,000. So it was initially 1,000, and now it says transfer 9,000 to Adam. So the only change is just one number. So here we have a note saying even a small change should cause HMAC verification to fail, because that's going to generate a different HMAC value. Now, so the message has been tampered with during transmission. We don't want to mention, or we don't want to dig into who did it and when and what and how. That's not the point. The point is that the receiver, in this case, will have received a different message than the original. But again, it's never going to trust that message until it verifies it itself. So it will recompute that HMAC again using the received message. So this is a newly received message with a secret key and using hash underscore mac and putting the result into a recomputed HMAC. I think I'm using the same. I'm reusing the variables for this demo, but whatever new values will actually be replaced. So any old memory or any old reference to these received or received message will change with the new ones. So definitely because the message changed, this is going to give us another HMAC value to the original one that was sent by the user. Okay, so now in step 10, the verification should fail now, but we're just printing out to the screen the received message and the recomputed HMAC. So before we see the result, let's save and refresh. we can see that the message changed, received message. That's in the second case. In the first scenario, it was a legit transfer. And the second one, we're just simulating an attack here. But you can see that the recomputed HMAC is actually a different value to the one that was generated for this message. So any change in just even one letter is gonna create a new HMAC. Now, when we compare that received HMAC that came from the original user, and like we said, this is going to be transmitted through HTTP header or request metadata. And then it's going to check that against the recomputed value. Of course, they're not going to match. So it should tell us that the message was tampered with and an attack is being detected. So let's refresh and we get exactly that. So this concludes our demo for this video. But having seen this is how the system will know if the data was changed in transit. So we take a message and a secret key and generate something called a HMAC. Both sides can independently generate this value. So same message, same key. The HMAC will match, like the first case here. However, change in any characters, even one, it will break the HMAC. So you can see how one change to just a number gave us a totally different HMAC. So this is used in APIs, webhooks, and secure messaging to detect tampering. And HMAC, really what it aims to do is it proves, and I think I wrote it somewhere here, it proves integrity and authentication. Thank you so much for watching this video, and I'll see you in the next one.